Hello and welcome to Chapter 13 of Building an Assessment Program. This is part of ISOL 536, Security Architecture and Design. My name is Dr. Alan Dennis. I'm your instructor. Jumping straight into the table of contents or the outline for Chapter 13, which again is about building an assessment program. We'll start off in section 13.1, talk about building a program, move on to 13.2 about building a team. 13.3 documentation and artifact, 13.4 peer review, 13.5 workload, 13.6 mistakes and missteps, 13.7 measuring success, and then 13.8 will be the summary. In section 13 or chapter 13, building an assessment program, security architecture calls for its own unique set of skills in the IT architect. For security architecture, the main ingredients will be the people and their skills to perform assessments and ultimately to craft and then drive security solutions. This comes down to the individuals and how to form your team. Other things to consider are pre-architecture engagement fosters discovery and inclusion of required security features. For new architecture, security engagement throughout the architectural cycle improves the integration of security requirements versus a one-time assessment. For existing architectures, only architecture changes need to be assessed and threat modeled. Any changes in design of security-related portions or components necessitates a security design review. Threat models are living documents and they change, thus must be kept in sync with changes in architecture and design. Agile requires continuous engagement since architecture and design are iteratively and parallel processes, parallel to themselves, to implementation and to testing. Moving into section 13.1, building a program. A program cannot be built solely from top down or completely from bottom up, or only across a peer network, but rather all of these must come together in parallel and also such that each vector of program development supports and strengthens the other dimensions. You will want to work on each of these dimensions at the same time. In my experience, there is no proper linear order, though it is true that without senior management buy-in, very little can successfully take place. That's true of pretty much every organization. 13.1.1, senior management's job. Senior management communications can be made through their usual channels, newsletters, and organizational all-hand meetings, blog posts through the organizational hierarchy as pass downs. The key trick here is this cannot be messaged just once through one single media channel. Various formats and vectors combined for a more powerful delivery. No one on the system delivery teams should be surprised when a security architect shows up and asks to see the architecture. This message doesn't have to be constant, but like all similar process-oriented communications, it will need to be repeated regularly. But there's more to that senior management must do. They must stand behind the empowerment. Smart people will push back. Sometimes the non-security people will have the best course of the company in mind. Remember, we all make mistakes. Everyone is fallible. 13.1.2, bottom up. In other words, when starting the program, plan for time for you and whoever is working with you to get out into the implementation teams and meet people, talk to them about security, find out what they think. More importantly, uncover fears about security, perhaps even poor experiences in the past. The latter is critically important. If you're wondering what a pre-existing social debt If you're working with a pre-existing social debt, you need to understand what the history is and how the debt was accumulated and what pain points originated with this debt. By visiting teams and simply listening, you can learn a great deal. That's almost always the first thing I do when I join a new organization. I go on a fact-finding mission. Is there any history with security architecture? Have there been failures? And if so, why? What are people constantly doing to achieve security objectives? Where do these security objectives originate? Who are the people who are engaged in security and what are their reasons for engaging? If I can, I try to identify who resistant and even potential enemies. And also along the way, you want to be identifying anyone that's a potential ally and an advocate, because it's not just figuring out where the problems might be, but where the opportunities are. In 13.1.3, use peer networks. If you are the director tasked with booting a security architecture and assessment programs, your peers will be the network through which most of the day-to-day resourcing and priority issues are set. Although it is true that line management often takes care of these task setting activities, if they run into trouble, it is your peer network that they will turn to. It is through your peer network that you need to influence priorities. Just as important as middle management, senior technical leaders strongly influence the success or failure of a security architecture program. First, security architecture fits in a social portion of an overall architecture, into a portion of an overall architecture of program and practice. That is, security is a specialty architecture practice that influences, shapes, and changes a system architecture within many organizations. Architects envision systems. Security architects envision the security of those systems. Although it is possible that both roles can be filled by the same person, these are usually different people in separate but highly intersecting bodies of practice. It is a disaster if the architect and especially architectural leaders are not supportive of security architecture. In this case, nothing will get done. And sometimes you may want to consider that an architect that is not the security architect may have competing agendas items with the security architect, and they may wish to prioritize certain things in different orders based upon the overall architecture of the solution. So sometimes having one person doing both roles isn't good. You may want that conflict between two individuals with competing agendas. You want to make the timing of activities perfectly clear in your delivery processor project lifecycle. There isn't much that can actually be done when the security assessment team takes a week or worse, a day before going live. Rarely have I seen decision makers stop deployment, even in the face of the critical security misses discovered during late assignments. And I've also rarely ever seen that. Typically, things will go out with some form of an exception instead, and with the understanding that they're going to be patched within a certain period. The idea is that it's too close. They're not willing to say no, even if it exposes the organization to great risk. Continuing the discussion of peer networks, Figure 13.1 is a whimsical visual representation of social networks that need to be cultivated for program success. As shown in the figure, socialize and keep evangelizing and socializing. Stay on message. Michael Gould says say it 3 times, then find different ways to say it. Prepare to perform years of repeated messaging. The effort to move a major public website's authentication from HTTP to HTTPS was the work of 3 different security architectures and took 8 years. It's important not to give up when a security requirement is the right thing to do, even in the face of significant resistance. Eventually, conditions will ripen in such things that the right thing can happen. And it's really quite amazing that it would take 8 years to make such a minor change, but some organizations are very challenging. And likely there were other issues that related to the HTTP versus HTTPS, like perhaps different domains and cross-scripting concerns. Moving on to 13.2, building a team. My teams typically encompass many fairly divergent cultures, most of the world's major religions, every stripe of political viewpoint, and any number of divergent value systems. All of this diversity makes for a rich stew out of which are born innovative approaches and synthetic solutions. If leadership can find value in a wide range of ideas, personality types, and then demonstrate that encouragement, I believe that building a truly global, high-functioning team must start with the first person or two, usually those who will be leaders of the team. To paraphrase the famous saying, physician, heal thyself, might be leader, lead thyself. Authentic leaders demonstrate a passion for their purpose, practice their value constantly, and lead with their hearts as well as their heads. They establish long-term meaningful relationships and have the self-discipline to get results. They know who they are. In 13.21, we talk about training. So how does an organization train people so that they can perform these difficult architectural tasks? Software security expert Gary McGraw says, for many years, I've struggled with how to teach people. security designs. The only technique that really works is apprenticeship. Short of that, a deep understanding of security design principles can help. Yeah, all the classes in the world may or may not help. Getting somebody to work with that knows their stuff, or working with somebody, if you know your stuff, and helping them come to speed is the way to teach a lot of these skills. Assuming that students already have some experience in computer security with system design, I teach in the following manner. Introduce security assessment as part of the security architecture, introduce security architecture in its entirety, but with a focus on security assessment in particular, delve into understanding architectures, practice architectural decomposition and following data flows, introduce the ATASM process, and analyze architectures and present case studies. The entire program benefits from the exposure of that active participation in a threat model gains. I walk through the ATASM process precisely as this book is laid out. Learn the architecture, gather all the threats, brainstorm, talk about what threats are relevant to this system as it will be deployed for its purpose in the organizational context. Discover as many attack surfaces as possible, and then consider existing security controls and possible mitigation strategies. One of the reasons that organizations perform security assessment is to help ensure that systems don't go live such that the system reduces the security posture of the organization in some fundamental way. This is a due diligence responsibility. In other words, the security assessment is, in part, an attempt to keep bad things from happening through the implementation and deployment of secure computer systems. Documentation and artifacts is covered in section 13.3. Security assessments must produce some documentation. Personally, I'm a big fan of keeping documentation as lightweight as possible, as am I. Generally speaking, less is better. However, some organizations have more heavy-duty documentation requirements. Any organization subject to certifications will have to produce sufficient evidence should the certification require proof that systems have been through a security assessment. Slightly different sort of thing. Proof of security assessment is not necessarily the same thing as the documentation that may be necessary for operation. So you may end up having to do both, but making sure that you meet the requirements of any kind of legislative or policies, but at the same time, keeping in mind, you've got to run the business. There are numerous creative ways to produce architectural artifacts that are understood and useful to the architects and engineers working on a system. At the same time, the same documents are evidence of the threat model that has been considered should your organization need such evidence. Rather than offering checklists and templates, my methodology encourages people to follow everyday path. Check every flow of interaction, identify all the inputs of the system. This approach does lead to peel the onion scenarios, which inevitably leads to backtracking through the ATASM process as new inputs and flows are discovered. I do find that this process does contain a map for completeness. It follows to conclusion, leaving no stone unturned. 13.4 deals with the peer review process. So what does a peer review process look like? What does an assessment require? When does an assessment require peer review? Who should perform the peer review? For large, complex, challenging systems, there's probably no substitute for a formal governance review. A common approach for this is to place senior and leader architects onto an architectural review board. The large or critical systems must pass through the review board and get approval before they can proceed. Sometimes the review board will also have a checkpoint before deployment into production. This checkpoint helps to ensure that projects that haven't met their deliverables can't move to production to the harm of the organization. A senior security architect will be part of the formal review board and have a no vote if there is a significant risk that hasn't been sufficiently mitigated. And sometimes that no vote is actually a veto, not just a no, but one vote could be sufficient to keep something out of production. This process does presume that architects will seek peer review. Architects have to perceive peer review as valuable, not as a hindrance. If the security architect understands the responsibility that they hold for the organization, my experience is that security architects generally like to receive some additional assurance on their assessment when they feel that all uneasy about what they've found, especially if they're seeing something new. Also, if you're attempting to launch something that hasn't been done before within an organization. If you have a company that's never had an internet presence and they're going to launch a website, you're going to need to make the security people feel much more at ease. And if you're the security person in that situation, you have every right to be concerned because the organization doesn't necessarily have the depth of knowledge about a new offering. The same thing would be true if you're offering a web application that's never been offered before or any emerging technology. And it's a reasonable expectation. What I've seen in most organizations is that the peer review process is a hurdle that must be gone over before you're actually able to deploy to production. You can do whatever up into proof of concept environments or even into quality assurance environments, but at the point you try to get to production, most of the time this is something that has to be done. And the reason that you can do it that way is that the people that do the deployment require it, and they won't let it go out without the review having been done. 13.5 is about workload. The problem of workload is further clouded by the simple fact that different people have different working styles. Some people can context switch very quickly, and some of these people may be able to retain a great deal of information about many different projects. At the other end, some very brilliant practitioners have trouble switching between context at all, and even two may be too many. New technologies emerge, new attack methods are discovered, and then there is the personal satisfaction that many security practitioners derive from staying up to date with the current security events. The right workload also reserves some amount of time for project-focused and basic security research. Besides, up-to-date architects generally deliver better and more efficient results or assessments. 13.6 is about mistakes and missteps. Although many experience doesn't perfectly match Murphy's Law, anything that can go wrong will. Uh, Mistakes and missteps do happen, it's true. Perhaps by articulating a few of mine, I can save you some from making the same errors. So 13.6.1, not everybody should become an architect. In that situation, there are numerous architects who don't have the capability, perhaps not the aptitude for which the architect role requires. And remember, these people were senior to a lot of the engineers with whom they were working. That means that even though architecture decisions might not be the best possible solution, those working underneath of these new architects might have to implement something that was not ideal. Indeed, some of the engineers could see the mistakes being made by the new architects, which led to a loss of confidence in the architectural process. This one mistake cost a 3.5-year halt in the development of what eventually took an industry-leading enterprise architecture practice. It took several years to filter out those folks whom would never gain the right skills or who didn't have the temperament, while at the same time having to wait for the development of those who would take the place of the poorly promoted lot. Not everyone can be an architect. Not every security person will be successful as a security architect. The lessons from these 3 years have burned into the way that I select candidates for the architecture role. And this is a very true thing and it's not just in security. Sometimes you'll end up with people that get promoted because of either seniority, favoritism, whatever it might be, that don't have the disposition to be an architect. Sometimes you'll get people that are too quick to try things, too willing to take risks. Sometimes you'll get people that are perfectionists that can't accept people doing things in a way that was different than their own. There's lots of reasons somebody might not become an architect. And there's even more reasons why somebody might not become a security architect. 13.6.2 is standards can't be applied rigidly. Frustrating teams escalated on a regular basis. Although there was no denying the contractor's security knowledge, the binary win-loss approach was causing projects to stall. Velocity to drop to a standstill, tempers to flare. Though the person was a nice enough person, certainly easy to work with on that team, that architect was not working out at all in any programmatic sense. After all, Architects, whether security or otherwise, are there to make projects successful. Part of the definition of success will be to attain an acceptable security posture. Acceptable is a qualitative term that cannot be stated for all situations with engineering precision. Acceptable has to be uncovered. So exactly what is it? One size does not all fit all, and revisited. Uh, Projects and changes to existing systems come in all varieties of sizes, shapes, and the amount of change. A successful program is easy to adopt when all who are involved acknowledge this variability up front and clearly. I can't tell you how many times an IT organization with which I've worked in the name of efficiency has built their delivery process around the biggest and most complex systems, not only to bury innovation and creativity in a landscape, only to bury innovation and creativity in a landscape of administration and bureaucracy. That's very true. It should be as good as you need and no more. That applies to every aspect of architectural and software development and security. You don't over-engineer anything. Do as little as is necessary, but yet still meets the goals. That's the guiding principle. 13.6.4, don't issue edicts unless certain of compliance. Edicts, unless based on the firm ground of necessity and obtainability, erode trust and support. In addition, if it is difficult if the directive is difficult or impossible to attain, such mandates cause your partners to create strategies of evasion or downright dishonesty, which means that you've made rules that people aren't going to obey and you won't know about it. I don't like to turn delivery teams into liars so that they can get their jobs done. Ethics should be avoided. You don't want to issue any kind of blanket statements because frankly, everything has exceptions. 13.7, measuring success. A poor measurement is the number of requirements written. A project that adheres to organizational standards will require few to no requirements. The security architect has done his or her job properly in this case. Adherence to standards is to be encouraged. My guess is you don't want your security architects to believe that achieving success is a matter of writing requirements. If you do, you may get a lot of meaningless requirements or even impossible requirements that projects can't fulfill. That's a very bad idea. But I've seen it proposed due to the lack of useful measures of success. Instead, here's some approaches that may help. Focus on innovation. Focus on delivery implies that anything excess that doesn't contribute to delivery is an impediment. Again, as little as possible to meet the requirements. If your architects are not being invited to meetings, are not being included in problem-solving discussions, this is actually exquisitely focused feedback. This first measurement of my program always is, are we being invited in and then asked to return? Because if you're not, maybe you're not being part of the solution. 13.7.2, establish baselines. Risk scores are interesting artifacts. First, these have to be gathered before assessments and sometimes around the final governance checkpoint or project go live. Intuitively, one would expect risk scores to decrease, but this is not always what happens. Take the example of a project that, before analysis, presents as wholly following organizational standards. This adherence to standards will cause the risk scores to be below. Then, as the onion is peeled, it is discovered that one or more of the implementation details of the project present significant organizational risk and are not amenable to the organizational standards. So something was there that you didn't know about. Such a situation is not common, but occurs regularly from time to time. I cited an example in my previous chapter. In this situation, the risk score is going to go up during the project delivery lifecycle, but the security architect is doing her or his job correctly. Upon thorough evaluation, security issues are brought into visibility. That's exactly the point of architecture analysis, to identify unmitigated attack surfaces. The teams will take initiative and write the appropriate requirements for themselves. Several IT architects who I worked with for many years began to finish my sentences quite literally. Over the years of ongoing collaboration, these architects developed assessment skills that were readily applied to their architectures. When security responsibility starts being taken throughout the architectural practice, this in and of itself is a sign of success of the program. In summary of Chapter 13, building a security architecture program is not a simple matter of hiring some smart people and then giving them some training. A successful security architecture program depends upon the support and collaboration of those who will interact and see the results of the program. Building a strong network of support is one of the key communication activities of the program, even a mature program. Finding the right people who have the relevant aptitude is in and of itself a non-trivial problem. Care must be taken to select for aptitude in a number of orthogonal areas: technical depth and breadth, communication skills, social ability, and a predilection to think architecturally about systems. Training can help to set up a firm base upon which these established experience. Naturally, I hope this book offers at least some basis of training for security architects who perform assessments. Typically, security architecture programs don't build themselves. There's a fair amount of care and feeding that's necessary to build successful security assessment programs. Not to be trivial, but it takes people, process, and technology. And with that, we conclude our discussion of Chapter 13. I hope you learned something. I know it was an enjoyable experience for me. As always, stay safe, and we'll talk again soon.